When we look at consecutive positive integers, we mean the numbers 1, 2, 3, 4, 5, and so on. If we had all consecutive integers, that would include the 0 and the negatives as well. So we're looking at whole numbers when we look at integers. When we talk about consecutive integers, you notice that each of these integers is one more than the next. So 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. So that means when we go to choose our variables, we can use x for the first integer, x plus 1 for the second, x plus 2, and so on. Now, as we get to consecutive even or odd integers on the next problem, we'll see that we have to use a different choice. This particular problem, number 23 from your textbook, we have to find 3 consecutive positive integers such that twice the product of the first 2 smaller integers is 88 more than the product of the 2 larger integers. When we talk about product, we mean multiply. When we talk about, I guess we don't see anything else in here but product. So let's go ahead and set up our variables. So we have 3 consecutive positive integers. That means that this x plus 1, and x plus 2 will work just fine. X will be the smallest, x plus 1 the middle size, x plus 2 the largest. Now we have twice the product. So let's make a product of the 2 smaller. So we're going to multiply the 2 smaller. So that's the product of the 2 smaller, x times x plus 1, and then twice that would mean to multiply again by 2. Now this product, twice the product, is, so that's our equal sign, equals 88 more than the product of the 2 larger integers. So we see the word 88 more. That means this is larger. In fact, it's 88 larger. So on the other side of our equal sign, we put the product of the 2 larger integers. So the 2 larger integers were the x plus 1 and the x plus 2, because we only had 3 consecutive positive integers. But they are not equal at this time. They're not equal. The left side is larger. So to make the 2 sides actually equal, we will add 88 on the smaller side. So the x plus 1 times x plus 2 is smaller. The left side is 88 larger. But now that we've added this 88 on the smaller side, now they are equal. So I'll go ahead and cross out the larger and smaller. This is the equation to solve. Often that's the hardest part, and you'll get most of your points for the problem if you can come up with the equation. The rest of the problem is solving for x. So let's go ahead and do that. On the left-hand side, we multiply the x times x plus 1, so x squared plus x. Then multiply the 2, so 2x squared plus 2x. On the right side, multiply out x plus 1 times x plus 2, so x squared plus 1x from the inners, 2x from the outers, that makes 3x, and 1 times 2 is 2. So on the right-hand side, there's x squared plus 3x plus 90. Now we'll go ahead and solve this. Because there is x squared, we want to get a 0 on one side and hopefully factor it then. So let's go ahead and subtract x squared from both sides, subtract 3x from both sides, and subtract 90 from both sides. What does that give us then? We have x squared minus x minus 90. equals 0. So as we go to factor, because this starts with x squared, we know it will be x times the x. And then because there's a negative 90, we need a positive number times a negative number to get that negative sign. So I'll put a positive and a negative. Then when you have large numbers like negative 90, you'll need to use a lot of trial and error probably. So just start trying. Negative 1 times positive 90, those add to 89, so not that. Negative 2 times positive 45, no, that adds to 43, and just keep working it out. I did this earlier, so I'm going to tell you what I actually got. I got negative 10 and positive 9. I guess I can use black again. Negative 10 and positive 9, because then I have 9x from the inners and negative 10x from the outers. So we factor, we set each factor equal to 0. On this particular problem, we needed the positive consecutive integers, so the x itself is 10, and then x plus 1 is 10 plus 1, or 11. X plus 2 is 10 plus 2, or 12. So the three consecutive positive integers are 10, 11, and 12, and you can go ahead and check those. Now let's take a look at the next problem, problem 36. Find 4 consecutive even integers such that the square of the sum of the first and the second is equal to 516, more than twice the product of the third and fourth. Now as you choose consecutive even, we're going to be going by twos, because look at your numbers, your integers. You see how the even numbers, 2, 4, 6, they increase by 2? So you can pick x plus 2, x plus 4, x plus 6, and just keep adding evens, because then your first even number would be your smallest, x, and then when you add 2, it gets you to the next highest even number. If x was 2 and you added 4, that would put you to 6, and so on. Now, strangely enough, we do the exact same thing for odds. So if this problem had asked, instead of even, had asked for odds, well, look at your odds. If x is 1, 3, the next odd, is 2 more. And 5 is 4 more than 1. So consecutive even and consecutive odds both use x plus 2, x plus 4, and so on for your variables. Now let's go ahead and set this up. In this one, we see the word sum. Sum is adding. And we see squaring, so we're going to put whatever it is in parentheses and square it. Okay, so the square of the sum, so first we'll take a sum, and then after that we square it. And the sum will be of the first and second. So first and second, that'd be the x and x plus 2. So that's what we're going to sum, x plus 2. And then that needs to be squared. So the square of the sum of the first and second, and that's equal, let's put an equal sign, equal to 516 more. So which one's larger? The first part that we're talking about, it's 516 more. So we're going to have the smaller value over here for a bit. 516 more than twice the product of the third and fourth. So there's that product again. Product, we multiply. What are we multiplying? The third and fourth. So the third is x plus 4, and the fourth is x plus 6. So here's the product of the third and fourth, x plus 4 times x plus 6, and then we have twice that. So twice the product, so we're going to multiply by 2. And right now, this is smaller by 516. So let's add 516 onto the right. And now it is no longer smaller. These are the same size. So let's go ahead and work out the algebra now. So there's 2x plus 2 in those parentheses. In the x plus 4 times x plus 6, we'll have x squared plus 4x plus 6x, that's 10x, plus 24. You could have first put 2x plus 8, and then 2x plus 8 times x plus 6, but we can multiply in this order also. On the left side, we're squaring. Remember, that doesn't mean 4x squared plus 4. It means to take 2x plus 2 and multiply it times itself. So you actually have 4x squared plus inners are 4x and outers are 4x, so that's 8x, and 2 times 2 is 4. On the right, there's 2x squared plus 20x plus 48. So what does 48 and 516 add to? 564. Once more, you'll see that we have x squareds, so we'll get a 0 on one side and factor the other. Let's subtract 2x squared from both sides. Let's subtract 20x from both sides. And let's subtract 564 from both sides. That gives 2x squared minus 12x minus 560 equals 0. This isn't going to be easy to factor, but it will be easier if we take the whole thing and divide by 2. We're able to divide both sides of the equation by 2, and that divides each term by 2 and gives us a little smaller numbers. Or you could factor the 2 out, but I'll just divide it away. So a little smaller numbers, but still very big. So be methodical as you sit and think about how to factor this, so you don't accidentally miss the answer. Since there is a negative 280, we again need a positive number times a negative to get the 280. So I'll try negative 1 times 280, that adds to 279. Negative 2 times 140, that adds to 138. Negative 3, that doesn't work. Negative 4 times 70, that adds to 66. And we just keep going, and I did this earlier, and I found 14 and negative 20. So 14x from the inners, negative 14x from the inners, negative 20x from the outers, that will add to that negative 6x. Let's set each factor equal to 0 then. So x is negative 14, or x is 20. This problem didn't call for positive or negative, just 4 consecutive even integers. So we have positive answers and negative answers. We have 2 sets of answers. So x plus 2, negative 14 plus 2 is negative 12. X plus 4, negative 14 plus 4 is negative 10. X plus 6, negative 14 plus 6 is negative 8. So that's one set of answers. Negative 8, negative 10, negative 12, negative 14. In this other case, if x is 20, 20 plus 2 is 22. 20 plus 4 is 24. 20 plus 6 is 26. So the other consecutive even integers would be 20, 22, 24, 26. Feel free to email me if you have any questions.